What makes Saturn so beautiful and mysterious? Could it be the awe-inducing rings? Or maybe because it has the most moons of any planet in our solar system? For me, Saturn has been my favorite planet ever since I've seen it with my own eyes through a telescope. In this video, I'm going to break down what makes Saturn so special. Now, let's start with the rings. Everybody knows Saturn's notorious rings. And even though it's not the only planet in the solar system with rings, it's by far the most prominent. Now, Saturn's rings are very vast in that from side to side, they're about 175,000 miles long. However, if you turn it sideways, the actual thickness of the rings is only a few miles in some of the thinnest parts. Every 13 to 15 years, when Saturn is angled in a way where the edge of the rings are shown, it actually looks like they completely disappear from Earth through a telescope because they're so thin. Actually, currently, while I'm making this video, if you go look outside through a telescope, the rings will actually appear very razor thin, and you might not even be able to see them at all. But what makes up Saturn's rings? Saturn's rings are made up of ice and rock particles, ranging from anywhere to small meteors to small little pebbles and dust. Another interesting thing about Saturn's rings is there's about 7 of them. They all orbit at different speeds around Saturn. The last thing that I'm going to talk about with Saturn's rings is shepherd moons interacting with the actual rings. So what shepherd moons are doing is it's the moons of Saturn, and they are also orbiting Saturn, but they are shaping the asteroids and rocks and ice that are Saturn's rings, and it's actually shaping them into that ring form, because without the moons guiding them, the rings will actually start to fall apart and lose shape. One last thing to mention about Saturn's ring system. There's a term called ring rain, which essentially means the small particles, both ice and dust and rock particles, in Saturn's rings are slowly getting sucked into Saturn by the gravity of Saturn, and they're being vaporized into the atmosphere or plummeting down to the surface of Saturn. This, in turn, is making Saturn's ring system slowly disappear, and not anytime soon or even in our lifetime will the rings cease to exist, but within millions and millions of years, Saturn's rings will eventually disappear. The first moon that we're going to talk about is Titan. Now, Titan is very unique in that it's the second largest moon in our solar system, second to Jupiter's Ganymede by about 2%. Speaking of Titan's size, it is actually larger than the planet Mercury. But just its vast size is not the most important thing about Titan. Titan is the only place besides Earth in our solar system known to have liquid in the form of rivers, lakes, and oceans on its surface. The bodies of liquid on Titan, however, are not made of water, but more so methane and ethane. The largest seas on Titan are hundreds of miles wide and hundreds of feet deep. However, it gets a little bit more interesting when you go underneath Titan's crust. Now, underneath Titan's crust is oceans of actual water, which is one of the reasons scientists are so interested in looking at Titan, because of the high potential of harboring life. Even though they're made of methane and ethane, it's still a possibility of life. This form of life would use a very different chemistry than what we're known to, but we can't rule out the option for life to form in other ways. And along with Titan's bodies of liquid, it actually has an atmosphere. The water cycle, similar to Earth, that actually happens on Titan too. It rains, there's clouds, and that rain evaporates and hence completes the cycle. Saturn's moon, Enceladus, is a small icy world that has geyser-like jets spewing water vapor and ice particles into space. Enceladus actually sprays its ocean out into space like a geyser, where spacecraft can actually sample the particles coming out. From these samples, scientists have determined that Enceladus has most of the chemical ingredients needed for life, and likely has hydrothermal vents releasing hot, mineral-rich water into its ocean. About as wide as Arizona, Enceladus also has the widest, most reflective surface in our solar system. Like some other moons of the giant planets, Enceladus is trapped in what's called an orbital residence, which is when two or more moons line up with their parent planet at regular intervals and interact gravitationally. Enceladus orbits Saturn twice every time Dione, a larger moon, orbits once. Dione's gravity stretches Enceladus's orbit into an elliptical shape, so Enceladus is sometimes closer and other times farther from Saturn, causing tidal heating with the moon. In 2005, NASA's Cassini spacecraft discovered that icy water particles and gas gush from the moon's surface at approximately 800 miles an hour. The eruptions appear to be continuous, generating an enormous halo of fine ice dust around Enceladus, which supplies material to Saturn's E-ring. Only a small fraction of the material ends up in the ring, however, with most of it falling like snow back to the moon's surface, helping keep Enceladus bright white. Since the ocean in Enceladus supplies the jets, and the jets produce Saturn's E-ring, to study material in the E-ring is to study Enceladus's ocean. The E-ring is mostly made of ice droplets, but among them are peculiar nanograins of silica, which can only be generated where liquid water and rock interact at temperatures at above about 200 degrees Fahrenheit. This, among other evidence, points to hydrothermal vents deep beneath Enceladus's icy shell, not unlike the hydrothermal vents that dot Earth's ocean floor. With its global ocean, unique chemistry, and internal heat, Enceladus has become a promising lead in our search for worlds where life could exist. Mimas. Its most distinguishing feature is a giant impact crater named Herschel, which stretches a third of the way across the face of the moon, making it look like the Death Star from Star Wars. The Herschel crater is 80 miles across, 1/3 of the diameter of the moon itself, with outer walls about 3 miles high and a central peak 3.5 miles high. The impact that blasted this crater out of Mimas probably came close to breaking the moon apart. Shockwaves from the Herschel impact may have caused the fractures, also called chasmata, on the other side of Mimas. Phoebe is roughly spherical and has a mean radius of about 66.2 miles, about 1/16 the radius of Earth's moon. Unlike most major moons orbiting Saturn, Phoebe is very dark and reflects only 6% of the sunlight it receives. Its darkness and irregular retrograde orbit suggest Phoebe is most likely a captured object. A captured object is a celestial body that is trapped by the gravitational pull of a much bigger body, generally a planet. Phoebe's darkness, in particular, suggests that the small moon comes from the outer solar system, an area where there is plenty of dark material. Some scientists think Phoebe could be a captured centaur. Centaurs are believed to be Kuiper belt bodies that migrated into the inner solar system. Centaurs are found between the asteroid belt and the Kuiper belt, and are considered kind of intermediate type of small body, neither an asteroid nor a Kuiper belt object. If Phoebe is indeed a captured centaur, images and scientific data of Phoebe taken by the Cassini spacecraft will give scientists the first opportunity to study a centaur. Prometheus acts as a shepherding moon, like we were talking about earlier, constraining the extent of the inner edge of Saturn's F-ring. And it also looks like a potato. The Hexagon Storm at Saturn's North Pole. The hexagon-shaped storm was first discovered by the Voyager spacecraft during its flybys of Saturn in 1980 and 1981. This hexagon storm is located at the North Pole of Saturn, and this storm's been going on ever since we discovered it, over 4 decades. Now, the size of this hexagon-shaped storm is about 29,000 kilometers or 18,000 miles in diameter. That's over twice the size of Earth. Now, my understanding of why this storm is hexagon-shaped is, well, first of all, I'm not a scientist, so this is my understanding of it, and scientists could have a more in-depth view of it. But basically, similarly to Earth, Saturn has, at each of its poles, polar jet streams, which for Earth looks like this wavy up and down pattern. However, on Saturn, because there's no mountains or oceans or anything of that sort, Saturn is just gas, and there's nothing to interact with the winds, so there's no reason for them to be wavy. And that's another reason why the storm's been able to go for so long, because there's no landforms to help break up storms like mountains and ice caps do on Earth. And another reason as to why the hexagon shape is there's a bunch of small storms on the outside of the hexagon that are kind of keeping it contained into its space. So it's basically one giant hexagonal storm, which its winds of like 300 miles per hour, like a mega hurricane that's over twice the size of Earth going on at its North Pole. And it's being surrounded by a bunch of tiny storms that are containing it into that hexagonal shape. And right at the very center of that hexagon is a polar vortex marking the North Pole that's in the middle of this giant storm. And also, just like on Earth, Saturn has northern lights, and it causes this amazing blue-looking aurora. Now this last section, for me, it's just all about personal experience, and I guess I've always been interested in space and exploration of space and what the human race could eventually do. And I guess why I'm so attracted to Saturn is, other than the moon, Saturn is the only celestial body that I've ever really looked at through a telescope. And the first time I looked at it through a telescope and was able to see its rings and the couple of moons that I saw, I'm not even sure which moons they were at the time. I didn't even know how many moons Saturn had. It was just seeing it for myself with my own eyes through my own telescope. It really put into perspective just how far away it is, and that it's real. Like, you think of space and Saturn and Jupiter and you look up in the sky, it's like, oh, it's a little tiny light. It's like, it doesn't feel real. But when you actually see it and its rings, it feels so much more personal. It makes you feel so much more grounded. It makes you have a different idea when you look up into space and you don't just see all these little lights. Those are stars, and all of those stars have planets and moons and asteroids and all of these different things. And just thinking about how vast the universe really is, it keeps me grounded in a way. It makes me realize my issues here that I have on Earth, just all of the problems that humans have. Oh, you had a bad interaction with somebody at a grocery store. Just thinking about it makes you not have to worry about all of these things. Like, none of these things that I'm dealing with are detrimental to my life, so why am I putting so much energy towards it? And I know that's probably some much more grandiose idea than just seeing Saturn and realizing that it's real, but it just puts it all into perspective for me, and that's why I took so much time making this video. I think it probably goes without saying, but this is definitely my highest production video that I've done so far, and I feel like it's just because it means so much to me, just because space has been such an interest of mine for a long time, and that Saturn is the first planet that I ever saw through a telescope, and it's just been my favorite planet ever since I was a little kid. But with that being said, I hope you enjoyed this video, because I really did have a lot of fun making it. And let me know if you have any recommendations of what you want to see next. But that's going to do it. See ya.